Hello, dear friends. Welcome again to my YouTube channel, Geotechnical Engineering Consultancy Tips. Today, I will be telling you all about soil testing for buildings, criteria for their geotechnical investigation. आज मैं आप लोगों के पास बहुत दिनों बाद ये नया लेक्चर लेके आ रहा हूँ। हम जब भी कोई अपना मकान बनाने जाते हैं, whenever we try to build a new sweet home or any building, then there is a necessity of subsoil investigation for that very building project to be done for its safety forever. This lecture will be covering building types, all building types, single, double story, lightly loaded residential building, a few storied building, commercial buildings, multi-storied buildings, and tall and super tall buildings. What is actually tall and super tall buildings with reference to IS standard code IS 16700 2023. And I would be explaining a few slides with the help of photographs also as well. Now, soil testing, geotechnical investigation of any building. What are the important points to be taken care of? Whenever you are starting your new building project, the subsoil investigation of that very building is a must for any preliminary design and finalization of the foundations for it. The object and scope of the investigation is to provide the structure designer information about the existing site ground conditions, including description of ground in the vicinity, as well as requirement of ground improvement and or treatment of foundations for the presence of harmful salts, if any, are found there in the soil or in the underground water. The geotechnical concerns of a site affect both the technical and the economical feasibility of the building. How the technical? If we are doing right kind of investigation, we are quick and feasible foundation for that very surface investigation of that very building. An extensive geotechnical investigation done at the very start of it so as to be able to suggest the most cost effective and safe foundation design solutions suitable for it. Yes. Site engineer in charge, architect, system. Now, the need for extensive and serious geotechnical investigation. Why is it necessary for every new building project? And the governing factors. The major governing factors for such kind of investigation are: first, we have to look for the kind of structure to be built. That is, whether the building to be built is single story or a double story building, whether it's a lightly loaded residential building or it's a few story building or a commercial building or a multi-story building or a tall or super tall building. And further, the site terrain where this construction of this structure is to be done there, whether it is to be built in plains or in hilly areas, kind of tentative anticipated foundation to be built for that very particular respective building structure based on the soil stratigraphy as well as the plan area to be covered by them. The above information in turn actually help us decide on the location of boreholes to be explored, the number of boreholes required to be explored at the respective site, along with the decision regarding the depth of boreholes to be explored. That is, the location, the number, and the depth of boreholes to be explored is to be decided, taking into consideration the kind of the building which we are going to build. Now, the necessity of subsoil investigation for any building project, issues which need be addressed. Number one is whether the soil or rock is present beneath the proposed structure that can safely support it in reference to its bearing capacity and allowed tolerable total settlement, differential settlement, angular distortion. That is, the building need be safe from shear criteria as well as the settlement criteria. Groundwater table. If it changes beneath the existing natural ground level, how will it impact the building structure during its lifetime? In reference to post-monsoon water table rise and or any others. For studying the impact of any excavation of backfilling on the foundations, recommending different kind of foundations for different kind of buildings based on the soil stratigraphy present, designing retaining walls for buildings with basements, assessing the responsiveness, stability, and safety of foundations towards any potential earthquake and seismic activity. doing liquefaction analysis of the site, assessing ground contamination, if any, their possible health safety hazards, if so, then devising methods to rectify it. That is, all these points need be addressed while doing subsoil investigation for any building project. Now, soil testing requirements for buildings, number and depth of boreholes in general. How do you decide? आप कैसे decide करेंगे कि आप किसी बिल्डिंग का soil investigation करने जा रहे हैं तो कितने नंबर और depth of boreholes उनमें जरूरी है उसकी soil bearing capacity report बनाने के लिए. That is, for G+1 and G+2 storage structures, you need to do at least single borehole of 6 meter depth or 8 meter depth or 10 meter depth. However, the number of boreholes can be increased based on the area to be covered by that building. For G+3, G+4 and G+5 structures buildings respectively, you need to investigate your soil vertically from the ground level to at least 12 meter, 15 meter and 18 meter depth. And the number of boreholes we decided depending upon the area to be covered by. However, any pre-decided depth of exploration need be extended at the site depending on the filled-up soil, any loose strata being encountered in between or near the borehole termination level, if any. That is, if you encounter any filled-up soil or loose strata, you have to increase your pre-decided depth of exploration for that very building. Now, another example. If the land width is quite narrow and the building to be built is high-rise, then the borehole depth should be around 1.5 to 2b, the anticipated depth width. That is, whatsoever is the least dimension of your building, उसका 1.5 से 2 गुना इन्वेस्टिगेशन डेप्थ हमें वहां साइट पे करनी ही करनी है, और इट में चेंज इंक्रीज फॉर पाइल फाउंडेशंस if required. That is, if we aren't able to have a safe red foundation for that very building, then we have to go in for deep pile foundations. And in that very case, it is always advisable to explore at least 3 number of boreholes for each such tower, and the depth should be sufficient enough so as to interpret the test results for recommending the most suitable foundation for that very high-rise building. Next. Now, I would be referring a few clauses of Indian Standard Code IS 1892 2021 for all of you. That is how the boreholes required to be explored for that very building project need be decided. That is the disposition of boreholes, trial pits, etc. as per clause 5.6.2 of IS 1892 2020. For lightly loaded residential building, such as single or double storied building, at least one borehole or trial pit in the center of the building need be investigated. But it is given as a note that boreholes are preferred over trial pits. Now, for buildings in a site covering an area of about zero point 0.4 hectare, at least one borehole in each corner and one in the center are required to be done at the site. Now, for these A, B, C kind of things, that is, A is for a structure building having any of the planned dimensions exceeding 50 meters. That is, whether its length or width if it exceeds 50 meters. Second case, for multiple buildings in a site covering an area of more than zero point 0.4 hectares. Third, that is point C, for multi-story buildings and a structure of height less than or equal to 50 meters. What is the requirement of the boreholes, the number of boreholes to be drilled? That is, the boreholes are to be explored in a grid pattern with points at not more than 50-meter distance. That is, the interdistance between the boreholes explored must be less than 50 meters, subject to a minimum of 2 boreholes, which this code specifies. Boreholes should cover the entire built-up area of those very buildings. Now, for multi-story buildings and a structure of height more than 50 meters, minimum 3 boreholes at each building and structure need to be explored right from below the ground level for that very structure. Now, the depth of investigation needed as per clause 5.6.3 of IS 1892/2021. The depth of investigation shall be, this first point which I am explaining you is very important, shall be adequate enough to provide necessary data for estimating safe bearing capacity and settlement for that very building. In general, the lines in bold need be taken seriously. The investigation shall be carried out to a minimum depth to which the increase in stress level due to the foundation load is lesser than 10% of the in situ stress level. That is, the depth of investigation also depends on the risk induced by the presence of weaker formations below the influence zone to be stressed due to the proposed construction. Now, what I mean to say is कि हमारा depth of investigation need to go at least up to this very level where the stresses are reduced to 10% of the in situ stresses developed, or if we encounter any weaker formations below this influence zone to be stressed, we need to increase the depth of investigation there at that very particular site location, at that very particular borehole location. I mean to say that. Now, if there are shallow foundations to be given other than depth foundations in soil. The depth of investigation shall be up to 2 to 3 times the estimated width of the largest foundation below the expected founding limit. That is, if your foundation depth is GF and your maximum estimated width of foundation is B, you need to explore to at least GF plus 3B depth below the natural ground. Now, raft foundation, if we are presuming that we need to give raft foundation, which in this very code explains that any width greater than 6 meter of the foundation need be considered as raft foundation for this very purpose with reference to this Indian Standard IS code 1892 2021. Now, the raft foundation is a substructure supporting an arrangement of columns or walls in a row or rows and transmitting the loads to the soil by means of a continuous slab with or without depressions or openings. In case of raft foundations, the depth of investigation shall be up to 1 to 2 times the width of the raft foundation below the expected founding level. Now, how do you decide the depth of investigation? If you are to provide pile foundation in soil, or you have to give foundations in rock, that is, you encounter rock during investigation. Now, for the depth of investigation, for pile foundations, which is needed, shall be sufficiently below the expected founding level of piles, that is the termination level of piles, but this should not be less than 5 meter or 5 times the diameter of piles, whichever is more beyond the estimated pile termination point to be noted. Now, penetration into rock, in case rock formation is encountered prior to the termination depth of boreholes as stipulated in all the prior above mentioned cases, these 5 cases which I have just mentioned, 3 cases are this one and 2 cases are this. The boreholes may be extended by a minimum depth of 5 meter in rock strata depending upon rock characteristics and project requirements. Now, an important point to note is that the depth of investigation may be suitably arrived as per the specific requirements for any other foundation substructure as specified in this clause 5.6.3 of Indian Standard Code IS 1892-2021-2020. Now, the decided depth of investigation. If you say you have a building, high-rise building to be built up, here is a building which is being depicted without any basement. Here is a building, the same kind of building with single basement, and now the same kind of building with 2 basements, the first basement and the second basement. Now, how would you have to decide your depth of investigation? In this very case, first of all, we have to decide the depth of investigation for this very particular kind of high-rise building. The number of stories are fixed and its plan area is decided. तो अब क्या है हम तीनों केसेस में कैसे डिसाइड करेंगे that is the decided depth of investigation which is being decided for this high-rise building without any basement need be increased in reference to the depth of basement floors below the natural ground level equal to the proposed height of the basement beyond the pre-decided desired depth of investigation, which was the case for without basement case, subject to the condition that the proposed height of the structure above ground level and its plan, etc., remains constant, remains the same. That is what I wish to say. If we have decided X meter depth of investigation to be done for this very building, and you are going providing their 3 meter basement floor, then you need to increase your depth of investigation of X meters by 3 meters. And in this very case, if you are providing two basements of say 3 meter each, accumulating 6 meter depth or say 7 or 8 meter depth, then you need to increase your pre-decided depth of investigation by this much 6, 7, 8 or 6, 7 or 8 meter, as is the basement depth below this natural ground. Okay. Now next. Now I am describing you a figure in which very case, as two slides prior, I have explained you if when we are going to provide pile foundations, then what is the minimum termination criteria of the above? That is, for this very high-rise building, these are the pile foundations, and this is its termination. So what the code suggests is if we need to explore at least 5 meter or 5 times the diameter of these piles below the termination level. That is, the depth of investigation need be done from this very ground level to this very level where I have written investigation depth termination level. And now, in which very kind of cases the pile foundations for buildings are proposed? Buildings with pile foundations are built in cases like when proposed buildings load requisitions are not being fulfilled by shallow foundations or raft foundations. When firm load bearing strata capable of supporting the structure's load being is available at quite a deeper depth, as in this very case, which I have described with the help of this very figure. Now, for high-rise buildings, which are to be built in narrow plan area, and they are not getting sufficiently good enough soil for this high-rise building to be constructed here, then you need to go in for pile foundations. For any other kind of things like filled up soil, loose strata, loose soil being present there for that very particular high-rise building, then you need to go in for pile foundations. And in that very case, this is the termination criteria. How you decide this depth of investigation for these very kind of buildings where you have to go in for pile foundations. Now, next, what has the change been there in India? The transformation from before 1990s to now. Before 1990s, buildings up to 8 or 10 stories were used to be built with internal partition walls of thickness 115, 150 or 230 mm. They had high unintended stiffness and they were heavy. Concrete frame structure, that is the RCC, reinforced cement concrete frame structures with partition walls were used, but the concrete walls were restricted to only the area surrounding the elevators or lifts, and the conventional formwork was used. That is, the height of the structures were not that too very large. Now, the trend now since 2000s, since the year 2000, tall buildings in cities from 25 to 80 plus stories. Partitions. Now we are using lightweight, thin, non-masonry partitions. Construction methodology has changed. Extensive use of modular formwork is there. Monolithic concrete construction of building shell. That is, आज की डेट में सन 1990 से लेकर के 2000 और आज 2024 तक, that is right from 1990s to now 2024, massive change has occurred in the size of the buildings because of the need of growing rapid urbanization. That is why Indian Standard Code has now launched Indian Standard Code IS 16700-2023, where it is describing the criteria for structural safety of tall concrete buildings. The first revision. Initially, it was published in the year 2017. Now, in 2023, it is the first revision. Now, what is this code addressing to? The large-scale urbanization in the country and shortage of land in urban areas for accommodating the vast population migrating thereto is being addressed through vertical developments in the form of tall buildings by this Indian standard IS code, IS 16700-2023. Clause 3.1.13, that is 3.13 of this IS code defines super tall buildings as a building of height greater than 250 meters. And the clause 3.14, that is 3.14 of this IS code defines tall building as a building of height greater than 50 meter but less than or equal to 250 meter. Now, what this code suggests as regards the depth and the number of boreholes to be done for these kind of tall buildings, that is, they should be spaced at the rate 30 meter within the plan area of the building. Minimum 3 boreholes need be explode at that very particular site for that very particular tower. The depth of burrows must be at least 1.5 times the anticipated width of the proposed air foundation in soil and 30 meters in rock. Now, the tall buildings with podium are during current times being built as per clause 8.1.3 of IS Indian Standard Code IS 16700-2023. The section 8.1.3.1 of this code deals with requirements for the following tall buildings with podium. That is, the tall building with single tower and podium, as is being shown in this figure 1A, and the tall building with multiple towers and common podium. Multiple towers 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and with a common podium. And in these very cases, your design requirements, your foundation requirements, etc., all changes, and that is why you have to necessarily do the sufficient depth of investigation in order to decide on the kind of the foundation, their respective bearing capacity, which is able to pass the shear and settlement criteria both. Now, engineers and my followers and my listeners, namaskar and thank you for your patient hearing. ये lecture थोड़ा लंबा हो गया. This lecture has been acquired. This quite has been a quite a long one. This is a quite long one lecture. Everyone is welcome to go through and follow the videos on Geotechnical Engineering at my YouTube channel, Geotechnical Engineering Consultancy, so on which I have uploaded 108 videos from the date of its launch till this date, excluding this one. My YouTube handle at the Geotechnical Tips Anurag Kapoor 79. You may contact me at 94155011637 or 6307997701 and at anuragkapoor16@gmail.com and anuragkapoor16@yahoo.co.in for geotechnical consultations. Search me by typing Geotechnical Anurag or Anurag Geotechnical or videos of Anurag Kapoor Geotechnical or by my channels. Thank you very much.